Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hello everyone and welcome. Thanks for joining me today. I will be talking about MeteorJS as a framework for hyperprompt development. I'll share my experience, a little story, my journey, and then I will show the demo where we will build a simple to-do app. But first, let me introduce myself. My name is Arman. I live and work in Netherlands. I'm based here. I have over 15 years of diverse experience. I started with Pascal, C++, Java, to modern JavaScript and TypeScript frameworks. Last 5 years, I'm focused on fintech. I'm helping banks and financial organizations with automation. And at some point in the past, I was a co-founder and a CTO of a successful software as a service company, where we were using MeteorJS as our main stack, main framework. But let me tell you how it still started. So our startup journey started at a hackathon called Startup Weekend. We built a simple prototype. We were building a MVP, showing it in conferences, pitching it, getting into incubator, where built more or less a product and finding market fit. Then we got investment, got into very nice startup bootcamp accelerator, second biggest accelerator at that time in Europe. Iterating over, finding market fit, finding investors, finally pitching in demo days. And all that journey was in like 4 or 5 months. Imagine how dynamic it was. And for supporting such a quick dynamic environment, we needed very good tech stack. What were our requirements? Because in a startup, basically you don't have a luxury to hire dedicated developers. So you have students, interns, some freelancers in helping. So we needed preferably the entire stack in one programming languages, and that at some points that one person can handle everything. We needed a quick learning curve so that we can onboard quickly some maybe students sometimes or some fresh graduates. And business-wise, we need a tool where we can quickly prototype, because sometimes you had a call from a client, needed something, then you would need to show working prototype by Monday morning, and then over the weekend you needed to build some prototype that works, and of course possibility of future development. I would say, for instance, it's not just prototype that you trash away, so you need to kind of develop it, and once the market niche is needed, so there should be a possibility to build a nice, good product on top of it. So that's where MeteorJS came in. That's the full stack JS framework that fulfilled all our needs. So basically, also our startup was in a personality assessment platform where we were recording personal data. So it was considered data of mental health kind of, and we couldn't host it somewhere in the cloud. So we had to have full control of data. So MeteorJS allowed us. And also it was a little bit more cost effective. It had a steep learning curve. So basically just in 1 week, it's possible to learn entire MeteorJS and start building. In 1 week, you can learn basically it from 0 to 90%. Then mainly it allowed us to do a quick prototyping, and for like future development, it supported React, Vue, Svelte, its own Blaze UI library. Also, it was built on top of MongoDB. It's very popular NoSQL database that is open source, and for the like a backend, it used Node.js. So for now, it was a more monolith full stack framework, and then it is possible to decompose it and then develop in future. To demonstrate how quickly it is possible to develop MeteorJS, I prepared a little demo. I pre-recorded this demo, and we will build a simple app. And it's a tutorial from official Meteor website. So you can go to MeteorJS, then you can find a tutorial. We will use React as our UI library, but you can use anything, and then you can go through the steps and basically in your own pace later. And once you complete that tutorial and you read a little bit of documentation, you're able to basically start building with it. Let's jump into demo. To set up Meteor project, we just run a command called Meteor create, and the name of the app. For example, we can call it Rapid to-do app. That's it. This command would generate, and by default, it would use React for the templating. Our app is generated, and we can open it in VS Code. It would have the following structure. So this is client. I would go through the main. So basically here in the servers folder, we'll have server-side code. So basically our backend. Here in the UI, we'll have our React application, APIs, and so on. We'll get back to that later. So let's run our application. We run Meteor run. And this command would start the Meteor application and would run it in localhost 3000. So let's wait for it a bit. Now that our application is running, we can go to localhost 3000 and render our application. So here it is. So I'll zoom it in or disable this. So yeah, we can see that we have click me and it's working. And yeah, let's proceed. Now we can see that we have app component. Welcome to Meteor. It has hello and info. Hello is showing the increment button and the label, and info some links. You don't need to understand the full project structure for now. What we need to pay attention is client folder is our root for our front end for web. So we can have main HTML, main CSS, and main JS6. This is like the root for our component that renders the app JS6. Here in the imports UI, we have our React components, as I mentioned earlier. And server side here, we have a Node.js code that connects to MongoDB. Now we are more or less familiar with the structure. Now we can start building our to-do app. First, let's create a task component. So create new file, task.js. Let's import React. We create component. So the task. So basically, we have a test component that receives task and then prints a text. Let's save it. As we are not connected to the server yet, to our database yet, so let's define the sample data, which will be used shortly to render a list of tasks. It will be an array, and let's call it tasks. So we'll have one first task, then we can we copy paste and let's do this. We have first task, second task, and third task. Let's save. Now let's render this list of tasks using normal React syntaxes. We can remove those components. Let's import our task component. Yep. Now get an audit list. So we map for each task. We would have our task component. We should not forget the key. That's vital, as you probably know. So we put task and the ID of it. Then actual task would be go to the task itself. By the way, let me make a font bigger. Yeah, I hope you can see it better maybe. So let's save it. Now we can see all our tasks, task 1, first, second, and third task. If we switch to mobile view, now we can see that it's not that pretty. What we can do is we can add some meta tags. So we add it to main HTML. So let's save it. Now it looks better. Meteor by default, when using React, is already adding a package called hot module replacement. That package updates the JavaScript modules in a running app that were modified during the rebuild. So this reduces the feedback cycle while developing, so you can view the test changes quicker. It even updates the app before the build has finished, and it keeps the state. Let's do a little cleanup and remove those unused components. Hello, info. Delete those. Trash, yes. Meteor has already set up MongoDB for us. And in order to use that database, we need to create a collection, which is where we will store our documents. And in our case, the documents would be tasks. And we can create a new collection to store our tasks by creating a new file at API, imports API folder. So let's create one and we call it tasks collection. Collection.js. So we import the Mongo first, then export. We can call tasks collection, which is Mongo collection, and we call it tasks. Did you notice that we used imports API folder? That is all code relates to publications, methods, and in general API. That's just convenience and choice. We don't have to follow the structure. For the structure that I'm using, we can use different ones. And we can do cleanup here as well. We can remove this links collection that was automatically generated. Okay, great. Now we can see some errors in the console log. It's because there is also some unused code in the server side. So we can see that linked collection was used, so we can remove this generated tag code, as well. So we can completely. This is a Meteor startup hook is run when Meteor app starts. So we can remove this one as well. And we can remove this import. Now our app works and we don't have errors. Since our collection is going to be empty in the beginning, let's populate it with the first values. So we import task collection. Then Meteor startup is the hook run when, as I mentioned, when the application starts for the first time. So for example, if the task collection, so we query through all the elements and then we count. And if it consists of 0 elements, then we can populate it with some mocks. So for example, we have first, second, and the third and the fourth task. Then we iterate. Actually, let's create an arrow function here. We call it insert task. Then for each task text, we insert it in a way that, this is function. So we insert into the collection. And now for each of those labels, we insert into our database. And let's save it. Now comes the fun part. We will render the tasks using React function component and the hook called useTracker. And that hook is from the package called React Meteor Data. This package has already been included in React Skeleton when we initially generated the project. Let's start by importing the useTracker. useTracker is a React hook that allows us to have reactivity in our React components. Every time the data changes through the reactivity, our component will re-render. Cool, right? So we'll also import the task collection, connection to our database, and so we'll refactor our component a little bit. So we would put the tasks inside, and we will now replace the mock data with useTracker. So we would need to find in a query. So we querying then we are fetching it. That's it. Let's save. Now you can see that we have 4 tasks that we previously added to the database. So basically now we're looking at the screen and we are getting the data directly from MongoDB. Now let's check our MongoDB. We can interact basically with Mongo using command line if we run Meteor Mongo command, or we can also use UI tool called NoSQL Booster for MongoDB. So we use localhost and 3001. So we connect. Now we can see Meteor. So we can see links and tasks. So basically, tasks is the collection with 4 documents. So we can observe here. So those are the documents that we just created. By the way, I will leave a link to this tutorial so you can later do the same thing on your own, step by step. So basically now we are seeing the tasks on directly from server to client. So we're going to explore later the publications and subscriptions. So basically, it's not going to be connected directly as it is now. Now we can perform a read operation from database. Now let's create a record operation. So basically adding a new task. To add new task, let's create a simple form. I'll create a new React component here. We'll name it task form. First, we need to create a simple form component to encapsulate our logic. As you can see, we use state React hook. So let's create a task form, and we use text and use state React hook with initial value of empty string. Then we create our form. Let's give it some class name. Then we have the input field. This type of, let's put some placeholder type to add new task. Then we add the submit button. We can name it, give it a label of a task, and let's save it. Let's give it a little more space. Yep, we'll make this one a bit smaller. Now let's add this form to our app component. So right after the title, we can say task form. Of course, we need to import it. Oops, no. Let's save, and we can see our task form. Let's first go to task form. Let's connect the input with the text state. So we add some more here. So value would be, would be a text, and a change event would be linked to set text. Set a target value, and that's it. And let's put everything into curly braces. Let's hit save. Now let's add on submit handler. On submit, we can call it handle submit. And that's the function that we need to declare here. So we can const handle submit. We receive parents. So first of all, prevent fault first. So what we need to do, of course, if there is no text, we don't need to save it. So if there is no text, then we'll just return. Otherwise, we can insert it directly to our database. So we use task collection dot insert. Here we pass an object. We declare the text is our text. So trim it. And let's add also created at, so we know when it's created. Later we'll use this field for arranging. So we'll have like we know the order when each task is so, and we also need to reset the state, save it. Now we can refresh our browser and let's try to add a task. So task 5. Let's press add. So yeah, we can see that 5th task has been added. It's here. Let's check the database. Yes, we have our 5th task, task 5, with created at. Now let's utilize that created at field, and of course when we add a task we want it to be added not in the bottom but in the top. To do that we need to go to our app component, and here first object is the search query, the second is sorting, so we can add one more. By the way, this is the standard MongoDB syntaxes. You can read more about it in the documentation. So I'll just quickly add sort and created at, and then -1, which means descending order. And we can save it. Yeah, now we can see the task 5 is here. Let's add another one, 6. Yes, it has been added. Now we can successfully read from our collection and insert documents. Let's take a look on how we can update and remove them by interacting via the UI. Since we are building a to-do list, we need a checkbox to check the tasks that we have done, that are completed. So let's implement that. You can open our task. And by doing that, by the way, we'll implement the update operation. So let's add the checkbox. Checked. Let's call it is checked. New attribute of a task. So initially they'll all be unchecked, and then when we click, by the way, let's pass on checkbox click. That would be event handler passed from outside. So we add that, we pass the task, put it read only. Let's make it a little bit more readable. And we close the tag. And also let's wrap text around span. Let's hit save. Now we can see checkboxes. To implement the toggle itself, we go back to app component. We create a toggle checked. This is handler function. Let's pass it to the task component on checkbox click. Go to toggle checked. That's it. So we pass the task, so we retrieve the ID and is checked from the task. Then here we start updating the actual record in the database. To do that, we use our collection.update. Then first we pass the ID of the record. Then we put set field is checked would be equal to the opposite of the current value, and that's it. Let's save it, and let's try here. So let's check 6, 5. Let's refresh our browser. Now we can see that we refresh our browser, but values are still there. So let's uncheck. So we have task 6 and first task checked. Let's check the database itself. If we check the database, we can see 6 is checked and the first task is checked. Let's uncheck the first task. We go back to database. First task is checked false. So now we are updating our record in database. Now let's implement the remove operator, the last one. So we need to be able to remove. To do that, let's go to task component. We'll add a little cross button. We'll pass it some handler later. So we can use times. Let's see if it works. Yes. Then we need to have a handler. Click. So by the way, here we add on delete click that we pass from the app component, and we add on delete click and we pass the task. Now let's jump into app component. We need to add that function. So we have toggle checked. Now let's add delete click, or delete task, delete task. That would be a function that gets a task, and from the task we extract its ID. And then here we actually perform the delete operator. So we do that by calling task collection dot remove, and we pass the ID. That's our function for removing, and now we need to add it here. Let's make this a little bit more readable. Let's key task and here we add on delete click. We go to delete task. Let's save it. Now let's try to remove first task. And we can see that instead of removing, it's actually toggling. So let's see what's the problem. Let's check the task component. And yeah, I accidentally put on checkbox click. So basically it's delete click. Let's save. And let's try now. We remove the first task. Yes, it's removed. Second task removed as well. Let's remove the third task and let's check back the database. And we can see we have 3 elements, 6, 4th, and task 5. It doesn't look that nice for now, so let's fix the styling. So I have prepared some CSS, so I'll just quickly paste it to save us some time. And now we need to add some more tags to our HTML. Let's do that. So we open our app. So I'll also, for the sake of time, just copy, paste the HTML tag. So I'll save it. So yeah, now it looks nice. Let's check if it still works. 6, then we put 7. Yes, it works. Then we can remove this 7. And let's rename it from welcome to Meteor to do list. And also let's put this little emoji. Let's also quickly implement a hide completed button that would hide a completed task and show. So basically, it's kind of another toggle. So let's define the state. So we can call it hide completed. So we use state, initial value of false. So in the beginning, it's not hidden. Then let's add the toggle button. We put some class name and button on click that would set the state to the opposite value, and the label of the button would be either show all or hide completed. And also let's import use state from React. That's it. Let's save it. Now we have a button. I would copy another styles and I would just add it here somewhere. I believe just in the bottom. So there are some styles for filter class. Let's save it. Now it's in the middle. Yep. Now it's we can see that state is toggling. Let's make this button work. Let's open app.js. First of all, let's create a filter. This would be extra logic for the filtering. Hide completed filter. Be equal to an object. So is checked. Would be. This is a special symbol of not equal to true. And then we would use it here. So basically, if let's put it down here so it's a little bit more readable. So if hide completed, then we would show the logic, otherwise it's empty. Then we can put sort down here. That's it. Let's save it. And we have a little error in the console because we have used the variable before it was declared. So let's replace and save again. Now let's refresh the browser. Let's hide. Now it works. That's it for the demo. For the sake of time, I'll stop here, but you can proceed on your own. So it is possible to basically Meteor has user accounts and authentication where you can use email and password or any other methods like GitHub login or Facebook login and so on. Also, I skipped the methods and publications. You can read it on the tutorial or in the documentation. So basically methods and publications are the security for the backend. And thanks for joining me today.